Hey, hello everyone. If you made it this far, you'll be at part 3 here with the Prime Crew Ingress. Let's go ahead and show you all the checklist here. This begins at T-minus 2 hours 40 minutes. Following that step will show no active checklist, and of course, as we go down to the time, boop, there it is. And I forgot to turn the auto exec off. There we go. I have updated my save since last time. You can see talkbacks are now a tad more realistic. So in order to speed things up, I just use auto exec to get to this point here. We'll ingress here on a left couch. CDR ingress is left couch. Suit power on. Power audio tone. Cabin fans will come on. And we'll verify some SCS switch positions that all look good. Lunar module pilot will now ingress the right hand couch. Suit power on. Power audio tone. Switch positions here on panel 3 will be verified. Oxidizer flow will now go to norm. And all the rest of the switch positions should be good. Command module pilot will ingress the middle seat. Comms panel is down here, panel 10. As controlled down. Suit power on. Power audio tone. Caution and warning to acknowledge. Suit H2O accumulator, suit water accumulator. Now that everyone's hooked up to the ECS here, turn that on. And we'll go uplink telemetry command to normal. Uplink telemetry command module to block. And the panel 10 here, PACCOM off. We'll prepare for our emergency detection system by switching the EDS power on and EDS to auto. Prepare for that emergency detection system test here, which will commence at the T-minus 1 hour 55 minutes. Probably a little bit before that, but our first cue as a observer without the space vehicle test conductor communications with us through the pad comms, since this is a simulator. Our first visual indication will be at the T-minus 1 hour 55 minute with the abort light coming on. While we're time skipping down to that time, there are some benefits to each crew member. Commander obviously gets to pilot the landing, pilot the rendezvous, basically pilot the LEM. Ironically, the lunar module pilot doesn't pilot the LEM. The lunar module pilot is actually called the systems engineer on the panel, so it's commander and systems engineer by the LEM operations book. That makes their roles a lot better, a lot better defined. So commander is the benefit of obviously being in command, piloting the landing, the ascent, whole lunar module mission. Lunar module pilot has a benefit, in my opinion, of flipping all the switches during activation and all of that jazz. I really enjoy, the tactile sense of flipping all the switches and stuff. So I vibe with that. Command module pilot has the benefit of quite a few times piloting the transposition and docking and the entry and, well, basically the whole command module. They actually pilot the command module. But another benefit is that they enter here last. There's a lot of time scheduled for these guys to get in the spacecraft and on the ECS, and there's gonna be like 7-8 people in here, flipping switches on the ground, crowding up their space. No room to stretch your legs. None. So command module pilot has a good because they're the last to enter. Um, they sit on a chair because obviously the suit is heavy as all hell. Uh, Weighs probably feels like a semi truck, and so they get to sit down in the chair, but they can stretch their legs, stretch their arms, and even the command module pilot gets to look out over the bridge, over the crew access arm, as the commander and lunar module pilot are getting in. The command module pilot, I've been told, kind of stands at the other end, and they get to see out and look at all the scenery from high up. So, a couple of benefits, I suppose, to each position, and last aboard is one of them, because I couldn't imagine sitting here for an hour without stretching my legs, because you're gonna hit the people, the suit technicians, and the backup crew that are currently in the spacecraft, getting some of the floor switch positions and getting you hooked up to the ECS, because you can't reach it from the seat. Like, I mean, come on, can you reach down there from the seat? Yeah, no, not gonna happen, especially with the suit on. So there's like a whole lot of time before they're swatted out, and you get to stretch your legs. Just saying, command module pilot benefit. You get to stretch your legs because you're the last one in, and once you're in and they all get swatted out after you're hooked up to the ECS, then, you know, everyone gets to stretch their legs at that point. There's, you know, not a lot of people in here, but, or not, it's just the crew at that point. But yeah, just a funny benefit by the rotation here of the boarding process that I did just want to point out, that comfort level in the space mission, while I would absolutely in a heartbeat do this, comfort level is definitely something to be desired. So you take it where you can get it, really. Although I hear the sleep in this thing is the best sleep you'll ever have in your life. So if you got back pains, just go to space. Abort light coming on now. T-minus 1 hour, 55 minutes. Abort light on. Once the abort light is off, we'll start the bulk of our EDS tests. Abort light off. Here we'll switch off some of the comms that we're not going to be using. That's the, excuse me, the intercom, VHF AM, and S-band. PADCOM will remain on for communication with the space vehicle test conductor in verification of the emergency detection system. Here on panel 6, lunar module pilot side, PADCOM will turn off just so that, you know, lunar module pilot and the command module pilot at this point can talk to each other without getting interrupted by the space vehicle test conductor. And inversely, the commander here doesn't want to hear the crew or the mission control coming in on the loop, so they will only talk to the space vehicle test conductor. It's the benefit of having, you know, something more than just a comms are on, like in Mercury. At the T-minus 1 hour, 40 minute mark of our count, the hatch will be closed, and they'll begin closing the boost protective cover. Shortly after that, a leak check will be performed. And once that's pretty much good to go, the pad crew will get on out of here. So, coming up at the T-minus 1 hour, 40 minute mark with cabin closeout. Really appreciate y'all taking the time to watch these tutorials. Of course, I wouldn't be posting tutorials without an audience, and I really appreciate that space has somewhat gotten a little bit more popular as the years have gone on. In small contribution to some of the privatized companies, politics aside, but a huge surge in and all kinds of people doing Kerbal Space Program, Orbiter, Reentry, a spaceflight simulator. Huge surge of people going to that realism side of things after Artemis 2. So that is outstanding. One mission was enough to spark the passion and the interest in space again, and I really want people to be engineers, to be software designers and engineers, to be pilots and astronauts again. There was such a lull in 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 America. There's this big shift from blue collar to white collar in a large portion of time, where they were telling Gen X and millennials, just go to school, go to college, get a degree, get a good paying job, and it just, this field was just not putting out, um, like it should have after the space shuttle program got canceled, in my opinion, prematurely without a replacement spacecraft ready. So I'm very happy to see a renewed and sparked interest in STEM. And, for a hot minute, there was really nothing to do besides technology. Um, and even then, a lot of people didn't really even like it. So I'm happy to see that renewed interest, technology that's going to something that's not AI, not spying on you. So that's a good thing. When a country decides to fight learning and STEM and higher education, that is a bad thing. Blue collar jobs are good. Obviously, there's a lot of highly technical and smart people in those fields, but I really appreciate that people are sparked to learn more than they did before and not just sit happily by doing their job, scrolling through short form content, and not learning about the things that are in front of them and the world. Space has brought that back. So, everyone that's new, welcome, and I'm very, very happy that even with all the budget cuts aside, that we've guaranteed ourselves one manned lunar voyage in our lifetimes. So let's all be thankful for that. That's, you know, these types of missions inspire world peace. So the more that these public-facing missions fly, and the people internationally have hands in building these spacecraft, not just from an engineering perspective, but also from a metallurgy, mineralogy, manufacturing, mining, all incredibly highly technical fields within their own right, bringing an entire world together and top to bottom sending people to the moon. It is something that contributes to world peace. So I'm happy it's happening. T-minus 1 hour, 35-minute mark. Switching the cabin fans to off. No change in your launch azimuth will be required. There was no countdown holds at all, so therefore no reason to change our launch azimuth. There would be other reasons to change it, but that is the biggest primary reason, is a count hold here at any time prior to this mark would affect our inclination relative to the moon, as Earth obviously would be rotating in the meantime, so a change in launch azimuth would be required to make that same landing site. That, however, will not be required at this time because we have had no hold. So we'll bring it down to the end of the EDS test here. If we missed it, the engine lights came and flashed on for just a brief second as part of the EDS test here. EDS standing for Emergency Detection System. And at the T-minus 1 hour, 21 minute mark, that test will wrap up. We'll get our comms back in a standard position, and we'll go ahead and disable the EDS power and the auto abort. While we got a little time, EDS is able to automatically initiate abort commands, and the automatic function is switched off following the mode 1 Charlie. Up at that point, the reaction time of a human is enough to abort manually, but it also gives the opportunity that, you know, you've got a lot of altitude, so if something happens and it's not critical to the launch, you're maybe want to you could diagnose it during the launch without immediately aborting. If your launch vehicle rates are picking up and you've got a launch vehicle guidance light saying that your instrument units failed, you can you can flip over to CMC then at the time after the S1C staging. You know, manually piloting to orbit is also an option that is available. So at the past the 1 Charlie mark, more options open up to you in terms of both time and procedures that can be done. Prior to that point, you've got dodging the pad up until 15 seconds where you clear the tower. That is the most critical part of the launch, the most dangerous. If your guidance software is off by even a foot, you're smacking right into that thing. So at any point in those first brief moments, you don't even want to think about pulling the abort. The system just does it. It does it fast. It gets you the hell out of there, possibly saving lives. Reaction time faster than a person. Things that would issue the auto abort here: anytime 2 engines were out, or anytime launch vehicle rates got high. The auto abort would be issued when the EDS switch is in auto. A little bit about this propellant switch here. This isn't part of a detection, but rather a mode. When you abort prior to 1 Bravo, the fuel will automatically dump from the command module if command module RCS logic is on. Hence why in a lot of launches this switch will be up like so. After 1 Bravo, you are high enough that you'll need to assist the tower in pitching the vehicle over after the tower has jettisoned. And when RCS is on RCS command, the command will be driven to on, and I believe the command module RCS will automatically pressurize. And transfer will automatically go to command module. So there are a few auto actions that happen upon abort, but after 1 Charlie, an abort cannot automatically be activated. After abort mode 1 Charlie, when you start getting to the abort modes where you could use the S4B, use the SPS, then at that point, I'm not sure if the command module RCS would be pressurized. That's something that I would have to look into, but I'm very certain that between 1 Charlie, or between 1 Bravo and mode 2, your command module RCS is going to is going to activate. Here at the T-minus 1 hour, 21 minute mark, the emergency detection system would be complete. We'll set ourselves up for the standard comm configuration for the pre-launch procedures, and we'll go ahead and flip our emergency detection system power back to off and manual, making sure these are on auto, and your launch vehicle SPS indicator is on angle of attack, as indicated by this small, written as a O in the checklist, looks like an A, but the technical term for that, I believe, is a Laplace. Taking us down to the guidance and control verification portion here at T-minus 1 hour. We are poised up in the Apollo 7 launch vehicle here, the Saturn 1B. And Apollo 7 does have a lot of procedures that are different, but a majority of the procedures are very, very similar or the same. And Apollo 7 takes you through almost every scenario you can freaking imagine on this thing. So that's why we're flying it, because we'll be doing like backup GDC align, backup IMU aligns, turning the computer off, turning it on, manual takeover of the S4B. We're going to be doing a whole ton of crazy stuff. A rendezvous with the sextant. It's going to be a fairly good time. Fairly good time. We're not going to do stuff like an Apollo 7 PTC or whatever. We're not going to do that. That's obviously way, way, way different. P23 is not going to be like an Apollo 7 P23 tutorial, right? Some of that, obviously, there's a level of ridiculousness to the amount that some of these procedures are different or vary in some way as a result of being in low Earth orbit. But we will, of course, be showing off the procedures that are largely the same. And because this mission takes you through damn near every switch in the cockpit, it's worth it. So I'm probably going to mesh the GNC stuff with systems stuff. Well, maybe not. This is for sure going to be a part of the GNC checklist, and I might just mesh it all together. Probably what I'll end up doing, and I guess maybe if people ask, I'll sort it out later, but for the time being, we'll just call it the new command module tutorials revisited, and we'll just throw everything in there for the time being, before I figure out what to do with it, because I don't know if separating out system procedures like I did last time, I don't know if that was beneficial or not, so we'll do a small bit of an experiment. We'll look at the metrics, and we'll see what people come up with, and what they want. T-minus 1 hour approaching with the guidance and control verification steps coming up. The first subsection of this will be a gyro power-up. So we'll take caution warning to normal. Oops. We'll verify our BMAG temp body-mounted attitude gyro temperatures are in the good. Lights are extinguished. And we'll power up the gyro. So FDAI GPI power to off. Body-mounted attitude gyros 1 to on, 2 to on. FDAI GPI power to both. We do that so that the FDAI doesn't drift as a result of the gyro power up. And we'll flick caution and warning to acknowledge. We'll start the GDC align subsection, and this will also be baked in with checking our needles. So we'll go ahead and FDAI select 1. Source to @set 152, 90, and 0. We will do GDC align. Push and hold. Once it's stable, release. Now we'll check our needles. 158, 81, and 355. So that full scale right, full scale right, full scale up. Very good. We'll check that functionality on ball 2. Ball 2 functionality is good. Switch is good. Attitude's good. The GDC align functionality is good. Pushing and holding. Release. Setting it back to 152, 90, and 0. Verifying full scale left, left, and down. Switching to ball 1. Same thing. Left, left, and down. And the reason we do it in this order is we verify full range in both balls in both directions, while not doing them one at a time for each ball. Like left, right, switch to ball 2, left, right. That's 4 times. Here we only do it twice. Very nice. GDC line, back to original launch attitude. No motion, and release. Gimbal drive check now. Batteries coming on. And as the main bus volts increase with the batteries coming up, lights get a little bit brighter. It's kind of a cool side effect. This is our thrust vector control servo power, part of the SCS. It helps inform the gimbal motors on how to drive themselves. They're a little bit like the accelerometers in the EMS or the IMU, except that they're attitude rate, so I guess they're more like the IMU than the EMS, but all accelerometers are really kind of the same, just either rotating or pendulous at this point in time. These are the rotating kind, detecting changes in attitude, which will inform the gimbal motors to counterproduce that torque. So pitch 1, start, and you hold any momentary switches for, at least half a second. Yaw 1, start. We do a trim check, click it to -1, looks good. +1 and 0. -1, +1, and 0. And we perform an MTVC check. That stands for manual thrust vector control. We'll just pitch up, center, pitch down, center, yaw left, center, yaw right, center. Very good. We'll activate the secondary thrust vector controllers. So secondary gimbals, pitch 1. Oops, excuse me, before we do that. SCS TVC to auto, so we get the auto switching. Pitch 2, start. Yaw to start. Translation hand controller to clockwise. That engages stabilization control system mode. Minus, plus, 0. Minus, plus, 0. And an MTVC check. Pitch up, center, pitch down, center, yaw left, center, yaw right, center. Auto switchover checks. So pitch 2 will turn off, yaw 2 will turn off. And verify that we get no manual thrust vector controls. So pitch up, center, pitch down, center, yaw left, center, yaw right, center. And we can see no response. That's good. DVC to neutral. We'll give it back to the CMC if the spacecraft control switch was on CMC. It is not. Set it to -1, -0.5. That's our launch trim. That's going to be different for future missions, but at that point, you just set whatever the checklist tells you to. That's part of your launch trim. Off and off. And the reason we trim out the SPS, even though it's not a part of the launch, is just in case of a launch abort. We want trim to the maximum weight center of gravity before the launch. Battery off, then auto. Off, then auto. If we were to lose a fuel cell or multiple fuel cells at that point, the main bus ties will kick in, tying the batteries to the bus, stabilizing our power. TVC servo power off and off. S4B launch vehicle SPS indicator to S2, S4B. We don't have an S4B, or excuse me, we don't have an S2, so that switch wouldn't be labeled that in the actual Apollo 7 cockpit, but no mission-specific cockpits yet. Yeah, I select 1, 2, source CMC. We'll now do the RSI test and setup. So that will be EMS roll on. And to push and hold the GDC line or any switch that's momentary, just hold shift, click, and release shift. We'll now take the yaw through 45 degrees. You can see it, 45 degrees, and we'll take it back to pointing up, which should be around 0. You may need to make some very fine-tuned adjustments, but for us, flat 0 looks pretty good. So we'll release, EMS roll off, and we've done that calibration, so we need to check our alignment to the IMU. We could see we just drifted just a teeny tiny bit here. Go ahead and fix that up. You can see much better alignment. We'll set the the EMS to the launch delta V's just in case of an abort. This one gets set to 2,000 feet per second. Again, this is one of those things that'll be different on the Saturn V, but just at this point, you'll set it to what the checklist tells you to set it to. There we go. Just get within the ballpark and use the right click for the rest of the way. EMS to delta V. And our next step will be the pad abort enable at T-minus 30 minutes. Taking us down. Stack looking very beautiful, and there is the moon in the middle of daytime, which is possible if you if you don't live under a rock, you know that, but it's very cool to see it out in the daytime, and very poetic. Oh, taking us down here, time skipping at 10x speed. Oh, and at this point, if you haven't, if you're on a bit of a slow computer, PCM bitrate to low, so you don't forget it for the launch. If you're on a bit of a potato-y PC, you can still play NASP pretty nicely on a low-end computer, but with this set to high, there is the chance of crashing during the staging sequences. Setting that to low, I personally find just frees up just a little bit more performance for you, because you're not bombarding your ports here for exporting telemetry to the telemetry client through your computer's built-in localhost network. If you flip that to low, it does lower transmission speed, so frees up more processing for staging and everything, and I just find it helps. On internal view, I've never really had a problem with it, but if you ever do like external view, you'll want that on low. Just trust me. Coming up at the T-minus 30 minute mark, we'll enable the pad abort system. And at the T-minus 20 minute mark, we'll activate the SMRCS, which is a procedure in all spacecraft. However, we'll also do a hot fire test, and that is an Apollo 7, I believe, an Apollo 7 specific procedure here. So that is an Apollo 7 specific procedure, so we'll still be doing it, but just know that not every mission does that. Pretty much, this is just about following the checklist. Until we get in orbit, we can get down to the nitty-gritties of the system, but I figure just in case people don't know where certain switch positions are that are most common during the launch, it'd probably be best to just film this part anyways. And last time I didn't even film any of this part, but some people like to know where all the switches are, so that's our next sequence. Sequence events control system arm, bat A and B, then the logic, A and B. These are circuit breakers. Logic 1 and 2 on. Misfin would give you the go for pyro arm, pyro A, and pyro B. And at this point, command module RCS logic on. So if we need to, we can dump. And at the T-minus 20-minute mark, we'll begin SM RCS activation. Start with our, what I like to call the Christmas tree. I get it from the World War II submarines. They called it the Christmas tree for pressure in the boat, for the vents and stuff on the interior of the boat. They turn green when they're sealed, red when they're open. These are obviously barber pole and gray, but just a bit of an homage, if you will, because it kind of looked almost exactly like this, just red and green instead of barber pole and gray. All right, T-minus 20 minutes with the service module RCS activation. We'll start with the SMRCS Helium-1 system. Pressurizes the fuel. Take a look. Probably won't be able to see it since we've been on ground support and we're fully tanked up. But we'll open the bladders up to the helium tanks. The bladders will expand and they'll pressurize the fuel. All in the gray. System 2. A, B, C, D. These A, B, C, D corresponding to the quads. Quad A, Quad B, Quad C, Quad D. Secondary fuel press at this time will be closed. And remember, no talkbacks for these, as you can see. This is the secondary propellant line, as opposed to or secondary propellant valve. So both will open in tandem on the primary propellant pressurization. So it's a little bit confusing, and I'm not sure why they designed it that way, but they did. So just something you have to deal with every once in a while. The checklist will tell you to close these. Just do what it says. Any sort of explosion or vibration during staging or TD&E, it could shock these valves open, so just make sure they're closed. Open, 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 and we've got fuel with the whole stack showing gray now. RCS command on. Auto RCS Charlie 3 and Alpha 4. Pitch up. Pitch down. Not too much, but not too little. We've got good fire. Bravo 3. Or excuse me, Delta 3 and Bravo 4 to main B. Yaw left. Yaw right. Looks good. And all the jets on. A, B, A, B. A, B, A, B. B, A, B. A, B, B, A. RCS command off. And then RHC all directions, verify no firing. Up, down, yaw left, yaw right, roll right, and we are good. Manual attitude pitch will be Excel command. We're already good there. And we'll just verify our GDC alignment, which looks spectacular. So we will omit this. So pro on that. FDI source to CMC. Select 1, 2. BMAGs will go to rate 1, the setting for launch. And with that, that begins the Prime Crew pre-launch checklist, with the launch checklist starting up at T-minus 15 minutes. So I'll go ahead and close this out there. Thank you all for stopping by, and I hope this wasn't too long for you, but the next ones will be quite short. So, thank you.